Hello everyone, my name is Kazi Hassan Mustafa and my other teammates are Hamza, Resul and Farhan. Today I will discuss about machine learning assignment 4. In this assignment, I will explain some techniques and that we learned in this semester, including data engineering, data augmentation and convent. I will explain how much I can increase the accuracy or decrease the overfitting. How can we use cross-field validation, and we will also discuss how many epochs are needed to create an acceptable model. The following assignment is a step-by-step process to implement a multi-class classification using weather classical dataset. The idea of current assignment is to intensify what we learned in deep learning. Firstly, I imported pandas as PD from keras.utils import nputils from keras import layers and models from scikit-learn model selection import steering test split. Then I connected with my Google Drive and mounted. Then I declare a variable file name and connected with my link. There, this is my CSV file. Then I read the first 5 rows from my data set. This is my data frame. You can see. This is my Excel file. Here is total 13 columns. Then I pick 11 rows from here, from second column to before the last column, and I call a variable x and put all the data. You can see. Then I selected another variable called y and selected the last columns from the data frame. Then I split the data x and the label y into training and testing segments and call them x train, x test, y train, y test. Then I define the x train. This is my x train. This is my x test. This is my y train, and this is my y test. After that, I check the length of x train and x test, and length is 292 and x test list is 73. Then I converted my x train and y test into categorical and call them one hot train levels and one hot test levels. And I took, then I printed one hot train levels and one hot test levels. Then I defined a sequential model that contained one attendance layer. First and second layer I used 100 hidden layers, and ReLU active. The third one I took dense layer as a number of output. Then I'll compile the model using RMSPROC as appreciate a loss function and accuracy. Then I calculated the result and evaluated X test, one hot test level. Then I fitted my model using epoch 20 and batch size is 10. You can see here the outputs. Now I repeated all I have done previously, a step with the following parameters. In the first and second layer, I used 10 hidden layers and relay activation function. And for the third one also, I use the same dense layer. I use the same setting as I have done before. Compile a phase using RMS prop. You can see here, this is my model. Then I fitted model using epoch is 20 and batch is 10. You can see my result. Then I calculated result evaluating X test, one hot test level for how the accurate my model is. You can see here my output. Then again I showed my model and you can see I used 25 epoch and batch size 10. Then I changed the number of layer and hidden units, compile parameter, number of epoch and batch size. You can see here I use 16 dense and here I use 15 dense and last one I use 10 dense. In general, if we have more number of layers or hidden units, we have get more accurate model. However, this also means the performance of the model will decrease when it has to process many hidden layers. Besides, model accuracy also depends on model quality and number of training data. Overfitting is machine learning. Overfitting in machine learning is very common problem, although it can be avoided. Overfitting refers to the situation when a model fits too well to training data but fails to fit new data. This happens because model over generalize the training data uh, to such a extent that it starts to memorize the noise is training data and um, it ultimately fails to predict the unseen data. A very good indicator of overfitting is high accuracy and low error rate for training data, but low accuracy and high error rate for testing data. To avoid overfitting, we can train the model with more data and reduce the number of feature of or parameter to make the model less complex by determining any redundancy. Now I will create a neural network and training network and draw a plot. Here I imported some all necessary libraries. Then I loaded my data sets and what encoded target value, convert integers to float, then normalize to range 0 to 1. Then I create a neural network model. This is my neural network model and this is my model summary. See here. And This is my train the network with training image and training labels. And this is my plot. You can see this is my accuracy. Training accuracy is blue one and validation accuracy is the red one. That's all for today. Thank you for watching my video.